All right, so we have the notes from lesson 3.4. For those of us in class, we've seen some of this, but for virtual students, we need to go over some of this, and we're just going to cover the big ideas, the big problems in here, and try to keep this somewhat short. And so what we're going to be doing is exponential and logarithmic equations again, but using our techniques, using our properties to solve for an x. All right, and so where we're going to start is using the properties that we know. And one of those is being one-to-one properties. So we can see that if it's base a raised to the x, base a raised to the y, we can set x, y equal to each other. We were using that one. Same with log base a of x equaling log base a of y. Since it's both log base of a, we can set them equal to each other. And then the big one here is these inverse properties, being like if it's a raised to the log base a, we know that the power rule brings the x down, and then the a log base a just cancels out. That goes to 1, and so that equals x. Same thing here. If we do log base a of a raised to some power x, the log base a and the a cancels out, and it leaves us with x. And so just a couple things to see this a little bit clearer is if we have things like the ln of x. The ln of x, well, to get rid of the ln of x, what we're going to do is going to do e raised to the ln of x. So let's say ln of x equals 7. So this would be e raised to the ln of x, e to the 7th. So bumping everything up to an exponent. And then the ln and the e cancel. And then you have x left with e to the 7th. So that's one thing that we're going to see a lot today. Another one that you might see today would be if you had maybe e to the x equals 8. Well, to get rid of the e and to get the x down, what we're going to do is we're going to take the ln of e to the x equals the ln of 8. The x is going to come down, so this becomes x ln of e equals ln of 8. Ln of e, that's 1, so that goes away, and you're just left with x equals the ln of 8. Okay, so there's another example of something we're going to see today. One additional one, and it works similar to like the first one I did, but maybe you have the log base 4 of x equals 16. Okay, so to get rid of log base 4, what we need to do is 4 raised to the log base 4 of x equals 4 raised to the 16. The log base 4 and the 4 cancel out, so this is x equals 4 raised to the 16 power, which is too big of a number for me to calculate. Okay, but those are going to be the big properties I use. Those are the inverse properties, and that's what I'm going to use mostly throughout the lesson. The first thing here is just talking again about rewriting so we could use one-to-one, rewriting so we could use different properties. So just one example, quick one here. We have 2 raised to the x equals 32. Some of us can look at that and say, okay, I know what x needs to equal because I know 2 raised to this power equals 32. I see it as 2 to the x equals 2 to the 5th power. Then I see it as 1 to 1, and so x must equal 5. I see that one way. All right, here we have, again, we're going to need to solve this for x. We're going to first use that we can combine this and turn this into division. And so this is the ln of x divided by 3 equals 0. Now here's what we can do. Because we have an ln, I want to get rid of it. I'm going to do e raised to it. E raised to the ln of x over 3 equals e raised to the 0. The e and the ln cancel. We have x over 3 equals 1. We can multiply both sides by 3, and you're left with x equals 3. One like this one's tough, okay? There's different ways you can see it. I like to see it as, instead of this being 1 over 3, this could be 3 to the negative 1 raised to the x equals 9. Well, when you have a power raised to a power, that's like multiplication, so we can multiply. We can multiply here, and here, multiply. And so this becomes 3 to the negative x equals 9. Well, one way to rewrite 9 is 3 to the negative x equals 3 squared. It's 1 to 1 from here. And so you can say negative x equals 2, which means x equals negative 2 as your answer here. All right, keep moving along. Just a couple more that I want to show. This is an example where we would take the ln of both sides. The ln and the e cancel out, so this is x equals the ln of 7. Here we got to do e raised to the ln of x equals e raised to the negative 3. The ln and the e cancel. This is x equals negative 3. This is log base 10 of x, and so that's got to be 10 raised to the log base 10 of x equals 10 to the negative 1. The 10 and the log base 10 cancel. This is x equals 10 to the negative 1. So you can see I'm using the same properties over and over and over again, so I'm going to skip through a little bit here. Here I have an example of this being 1 to 1, so I can set these equal to each other. This would be negative x squared equals negative 3x minus 4. Adding x over, this is 0 equals negative x squared. And then I could keep going from here. Sorry, I added that over, so that's going to be positive. Minus 3x minus 4, and solve it using factoring. So I could factor that and solve for x. There's only a few more that I'd like to show here. One being maybe this one here. Okay, and so again, I'm solving it for t. I got to add 4 over to both sides. So this is 2, 3 to t minus 5 equals 15. Divide both sides by 2 here. You got 3, 2t minus 5 equals 7.5. I need to somehow get this down from the exponent. So I know that if I use logarithms or natural log, I can use the power rule to bring something down. So I'm going to take natural log of both sides. So this becomes 2t minus 5 times the natural log of 3 equals the natural log of 7.5. This one becomes dividing by the natural log of 3. I have 2t minus 5 equals the ln of 7.5 over the ln of 3. I can add 5 to both sides, so 2t equals the ln of 7.5 over the ln of 3 plus 5. And then lastly, I can divide by 2. So I got t equals the ln of 7.5 over the ln of 3 plus 5, all divided by 2. And that would be my answer there. Okay. This will be the last example I show before. Actually, I had 2 more. This is the second to last one. And this is just because I want to show us substituting a different variable in. So this is like e to the x squared minus 3 e to the x plus 2 equals 0. I'm going to replace all of my e to the x's with y's, okay? Because it's going to make this way easier for me to factor. So this is what I'm going to do. This is my next step. I'm going to say e to the x equals y. And I'm going to plug in y for all my e to the x's. So this is then y squared minus 3y plus 2 equals 0. And I'm going to then factor. Okay, so I need to multiply the 2, add up to negative 3. And so this is going to be y minus 2, y minus 1 equals 0. I'm then going to replace, so I have y's, but now I don't want y's anymore. I want e to the x back. So I'm going to retake my y's and set them back equal to e to the x. And so this is e to the x minus 2, e to the x minus 1. Set them both equal to 0 now. E to the x minus 2 equals 0. E to the x minus 1 equals 0. This would be e to the x equals 2, e to the x equals 1. ln of both sides in both cases here. So these cancel, and I'm just left with x equals the ln of 2, x equals the ln of 1, and those would be my answers there. Lastly, on a problem like this, we need to look at our compound continuous equation and then say, okay, this is what I have, this is what I'm looking for. Because now that we can take things out of the exponent, we might look for a thing like we have here, like we're looking for time. How long will it take? We're looking for time. And so what I have is a principal in a beginning interest of 500. I have a rate of 0.0675. I have T is what I'm looking for. T is what I don't know. And I know that we're looking for how long it's going to take for it to double. So my equation is A equals P e to the RT, A per. Well, my final answer, so I have my P equals 500. Doubling 500, that would give me 1,000. So we're looking for how long will it take to get to 1,000. E is E. The interest rate is 0.0675, and T is what we don't know. And so I need to solve this equation for T, and I start by dividing by 500. And what I get then is 2 equals E raised to the 0.0675 T times T. I can take the ln of both sides. And by taking the ln of both sides, I can bring this exponent down. So this is 0.0675 times T times the ln of E. The ln of E is equal to 1, so that goes away. And then what I have is the ln of 2 here equals 0.0675 T times T. Divide both sides by 0.675. And I get my answer that T is equal to the ln of 2 divided by 0.0675, whatever that is. And so again, I'm just using properties to solve for something that was in the exponent. Okay, and that would be the only one I want to see. If you want more examples of using this, then please let me know. Here was the homework that I posted. And if you have questions, again, please just let me know.